there. This is Dr. May. Welcome to our video. We're going to be talking about solving one-step equations. I think it's important for us to get started with what a solution is. And a solution is simply a value that when we substitute that value into an equation in place of the variable, it makes the equation true. So when we use the word solve in our instructions, we're looking for find the solution is what we're really trying to say. Now, I need to say this before we get started. When we're solving one-step equations, you may be able to look at this equation and say, oh, I know what number should go in place of the P. And that would be great. Except that what we're trying to do in this video is to build some skills so that if you look at some of my other videos like the two-step equation, the multi-step equation, variables on both sides of equation, you're going to have the skills you need in order to solve those more difficult equations. So I'm going to use that approach in this video. So let's take a look at P plus 5 equals negative 10. Now what I want you to do is to ask yourself, what is happening to the variable? What's happening to P? Well, it's pretty easy because you can look right beside the P. It's being added by 5. So what we're going to do the opposite of that. So the opposite of adding 5 is to subtract 5. Now I want you to notice I wrote it right underneath the plus 5. And then I'm going to do the exact same thing on the other side of the equal sign. So I want you to think of there being like an imaginary line there at the equal sign. And I'm going to do the exact same thing, the minus 5 on the other side. Now you may think, well, why did you do that? And here's the reason why. Because on the left side, plus 5 minus 5. So if I give you $5, then I take $5 away. Those cancel out. They give us 0. And that's what we want is we want these to go away so that we have P all by itself on one side of the equal sign. Now, if we look at the other side, negative 10 minus 5 would be negative 15. Now, if positive and negatives kind of make you a little bit nervous, feel free to check your calculator. Use the free online graphing calculator at Desmos. I've linked it down below in the description. Now, this we say would be the solution to our equation. So watch what a solution does. A solution, we take the original equation and we can put the solution in for the variable. So in place of the P, I'm going to put that solution of negative 15. And what we're trying to determine is, well, is that true? Is negative 15 plus 5 equal to negative 10? The answer, yes. So we do know that P equals negative 15 is our solution. All right. Now let's look at problem number 2 then. I want you again, focus in on that variable. This time it's an R. Ask yourself, what's happening to the R? It's being subtracted by 2.6. So we're going to do the opposite of subtracting 2.6, which is to add 2.6. And remember, we have that imaginary line happening at the equal sign. So that whatever we do to one side of that imaginary line, we've got to do to the other side. Now, the reason we did that was so that these minus 2.6, the plus 2.6 would cancel out. I'd be left with just an R on the right side, and on the left side, negative 7.5 plus 2.6, again, gives me that negative 4.9. Okay. Again, if you're having trouble with the positive and negatives with the decimals, use your graphing calculator, free one available at Desmos. And I put the link down below. And you can check out that arithmetic there. Okay. All right. Let's look at a few more. If you'll notice, I'm getting a little bit more difficult each time. Okay. So that's very intentional. I like to take my students from very simple and we gradually get more difficult. So look at number 3. M plus negative 34 equals negative 21. I'm going to go ahead and put that imaginary line at the equal sign. And I'm asking myself, what's happening to the variable? What's happening to the m? It's being added by negative 34. So we're going to do the opposite of adding negative 34. You may say, well, that's subtracting negative 34. And you're right, it is. However, it might be a little bit easier if we do the opposite by adding positive 34. Do you see how I did that? Let me say that again. You could subtract negative 34 from both sides. That's a lot of negatives going on. So what I like to do is do the opposite by adding positive 34 to both sides. Okay? If you didn't know we could do that, you can. And I hope that helps. Now remember, the whole purpose was to make this negative 34, positive 34 go away. And we're left with m equals negative 21 plus 34 gives me positive 13. Now, how do you like that? Are these getting a little simpler? I'm hoping you're starting to see the pattern. We are using a lot of the same techniques each time. That's intentional because I want you to feel like we're not reinventing the wheel each time. Look at number 4. I've got r minus negative 8 equals negative 14. Now that minus a negative, I don't know about you, but that looks a little odd because I've got a lot of negatives going on. So I like to go ahead and add a line to that addition and change the sign of the next number. So again, I change that r minus negative 8 to r plus 8. Now, I don't know about you. That just looks like an easier problem to solve. So I'm going to put our imaginary line here. And then I'm going to look at my variable, ask myself what's happening to the r. It's being added by 8. So I'm going to do the opposite, which is to subtract 8 from both sides of that imaginary line. And then I'm going to mark out my plus 8 minus 8. That was the whole reason we did that. And we did that so that we could get r by itself equals, and then negative 14 plus negative 8 gives me negative 22. All right. Now, these 4 problems have focused on if the variable is being added or subtracted by a number, okay? We want then to take a little bit more time with what happens if they're being multiplied or divided. I got a nice little variety here. If we look at number 5, see what's happening to my variable here, what's happening to the t. It's being multiplied by negative 5, you're right. So I'm going to do the opposite of multiplying by negative 5, which is to divide by negative 5. Just like we did before, the purpose was to let the multiply by negative 5, the divide by negative 5 cancel each other out. And that gave me t by itself over here. And then 60 divided by 5, no, sorry, 60 divided by negative 5 gives me negative 12. Okay, we can do the same thing with the decimal problem here in number 6. We ask ourselves what's happening to our variable n. It's being multiplied by 2.3. So we're going to do the opposite of multiplying by 2.3. The opposite is to divide by 2.3 on both sides. Just like we did before, we are going to let those cancel out. That multiplying by 2.3, that dividing by 2.3, so that we are left with just an n. Okay, and then this is where I'm definitely pulling out my calculator. 115 divided by 2.3 gives me 50. All right, let's do a couple of one division here. I look at number 7. I see the variables being divided by negative 4. So I'm going to do the opposite of dividing by negative 4, which is to multiply by negative 4. So I'm going to multiply by negative 4 on both sides. Now you can write that multiply with that little time symbol. You could do it with a dot. The big deal is I want you to see that we did it to both sides of the equation. That's important. Because I know that multiplying by -4 and then dividing by -4, that cancels those out, so that I'm left with an r over here, and that equals 15 times -4 gives me -60. All right, now I've got 2 fraction problems left. These are probably the ones I get the most questions on. So let's go slowly through them, make sure we understand everything we're doing. I have my line, my imaginary line at the equal sign. I ask myself what's happening to the variable. It is being multiplied by 2/3, being multiplied by a fraction, okay? So if we're going to do the opposite, we would divide by 2/3, okay? Which is fine. You can divide by 2/3. However, we know that when we divide by a fraction, it's the same thing as multiplying by the reciprocal. So let me show you what I mean. I'm going to, instead of dividing by 2/3 here, I'm going to multiply by the reciprocal, which is the flip. So instead of multiplying by 2/3, I'm going to multiply by 3/2. I'm going to multiply on the other side by 3/2 as well. Now you may say, Dr. May, why are you doing that? Well, let me show you. Because multiplying by 3 and then dividing by 3 cancels out. See, those 3's cancel. Multiplying by 2, dividing by 2 cancel out. Remember, the whole purpose of what we're doing here is to get that b by itself. Now look what happens on the other side. I'll make this 12 over 1. So now you can multiply your fraction. 12 times 3 gives you 36. And on the bottom, 1 times 2 gives you 2. So 36 divided by 2 gives you 18. Okay, so the moral of the story here is that when you have a fraction being multiplied times the variable, you can multiply by the reciprocal. Remember, that's where you flip the fraction. Let's do one more like that so that you feel comfortable with it. I'm going to put my imaginary line here. Ask myself what's happening to the variable. It's being multiplied by -4/3. So we're going to multiply by the reciprocal on both sides. Yes, you need to multiply with the negative. Let me show you what I mean. I just rewrote the problem there. And now I'm going to multiply by the reciprocal. That means I'm going to flip it. See how I put the negative on the 4? You need that in order for it to fully cancel. Okay? All right. Like before, multiplying by 3, dividing by 3 cancels. Multiplying by -4, dividing by -4 cancels, leaving us with just an x over here. Now over here on the left, I'm going to make that 16 over 1 so I can do my multiplication pretty easy. So 3 times 16 gives me 48 on top. -4 times 1 on the bottom gives me -4. And 48 divided by -4 gives me -12. So those are our examples of one-step equations, and those are simply just one thing is happening to the variable, and this is how we did the opposite of it in order to get the variable by itself. Now, these are definitely good practice to lead into my two-step equation video, which I'll be sure and link below so that you can go ahead and check out how do we solve it when we have two things going on. All right, friends, thanks so much. Have a good day.